Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at rational and irrational numbers. So a number is said to be rational if you can write it as a fraction in the integers and it has a terminating or recurring decimal. So what does that mean? It means any fraction with integers is a rational number. So 3 over 8 would be a rational number. 3 over 8 has a recurring decimal, 0.375. So 0.375 is also rational because these two are the same number. Something like 5 over 11. That is a fraction in the integers because it has an integer numerator and denominator. So that's a rational number. So if you were to convert this to a decimal, it would be 0.45 recurring. So 0.45 recurring is also rational because it's the same as 5 over 11. So a rational number is a fraction with integers, and what that means is because any fraction with integers can be written as either a terminating or recurring decimal, every recurring decimal is rational, every terminating decimal is rational. Note that this also includes whole numbers because something like 5 is the same as 5 over 1. So that has a terminating decimal that is rational. So whole numbers are included in rational, as are any fractions with integers for numerator and denominator, and consequently all terminating and all recurring decimals are rational. So you might be thinking to yourself, hang on, aren't they the only two options? A decimal can be terminating or it can go forever and be recurring. Well, there is actually a third option. You can have a decimal that's neither terminating nor recurring. So terminating means decimal stops, recurring means it goes forever, but there is a pattern to it. So an irrational number will be a number that has a decimal that goes forever, but there is no pattern. So one of the most famous of this is pi. So pi is equal to 3.14159. It goes on forever. I'm just writing here a lot of decimal points because I want you to see that there is no pattern. There is nothing recurring. There are no numbers here, no set of numbers, no rep 10 that occurs infinitely many times. It's almost like whichever number comes after the decimal point is completely random. So pi is irrational. You can't write it as a fraction in the integers. Of course you could write pi over 1. That is a fraction, but the numerator is not an integer. You can't actually write pi as an integer divided by another integer. So pi is an example of an irrational number. So other examples are when you square root a non-perfect square. So remember, perfect squares are numbers that are an integer multiplied by itself. So perfect squares include 1, 4, 9, because 9 is 3 times 3, then 4 times 4, 5 times 5, and so on. Now, all of these numbers is a whole number, so it's rational. But if you square root a number not on this list, you'll get an irrational number. For example, you'll see that 2 is not on this list. 2 is not a perfect square. So 2 is rational, but the square root of 2 is irrational. Square root of 2 is about 1.4142. It has a decimal that's neither terminating nor recurring. If you were to put root 2 on your calculator, you'd get a decimal expansion that goes forever, but there is no pattern to it. Of course, something like the square root of 3, that is irrational because 3 is not a perfect square. But the square root of 4, that's rational. The square root of 4 is just 2. 4 is a perfect square. If you square root one of these perfect squares, you get a whole number, so it's rational. But if you square root a number not on this list, if you square root a non-perfect square, you get an irrational number. You get a number whose decimal expansion goes forever but has no pattern to it. So neither root 2 nor root 3 can be written as fractions in the integers. So when you add together a rational and an irrational, you get an irrational. Square root of 2 minus 3, for example, that will be irrational because root 2 had a decimal expansion that was neither terminating nor recurring. Subtracting 3 from it actually won't change its decimal expansion. So that actually extends to all cases where you have a rational and an irrational. For example, the square root of 5 is irrational. So if you take away 0.2 recurring from root 5, you will get another irrational number. All right, let's look at this question. Find a rational and irrational number more than 1 but less than 2. So finding a rational number between 1 and 2 is actually quite simple. Let's just give an example of a terminating decimal. So an example would be, say, 1.4. 1.4 is rational because it's a terminating decimal. You can write this as a fraction in the integers. 1.4 is 7/5. What about an irrational number? Well, we can use our list of perfect squares here. 1 is the square root of 1. 2 is the square root of 4. So we just square root a non-perfect square between 1 and 4. As we did before, the square root of 2 is an irrational number. It's more than 1 because it's more than the square root of 1, but it's less than 2 because it's less than the square root of 4. You know, you could have also put in the square root of 3. You could have put in the square root of 2.2 because 2.2 is not a perfect square. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.